Alright, so we'll be on the cover, and we're going to look at one kind of example, and we're going to summarize kind of what we just did, the graphical approach, the unit circle approach. Which one is more efficient for us? Unit circle, that's what we're going to use, alright? But it's good to have both, so you can see the connections. What are all the solutions So what are all the solutions for sine of x equals rad 2 over 2? And to look at this, we're going to look at two different representations. The first one being a graphical approach. And the second one, we'll look at the unit circle. Alright, so we'll start with the graphical approach. Oops. Alright, so here's your sine function. We have pi, we have 2 pi. We also know that our range here is 1 and -1. And I'm going to give you a little bit more information. You don't have a calculator, but if I was to put this in your calculator, rad 2 over 2, the decimal you'd come out to is about 0.7. Okay? So, kind of just to help us graph this, if we were to look at it, 0.7 would fall right around here. So if we found our two solutions, we would have one here and one here, both of them being less than pi. Now this isn't the most efficient approach for us. The unit circle works better. So before we draw the unit... Alright, Javon, where's one of them? Okay, good. And Stephanie, where's the other one? Perfect. So how many solutions do we have? Does our graph support that? Yeah. Now, let's draw the unit circle so we can actually see the connection here. There's our circle. Thanks, I've been working on it. Alright, and your knowledge of the unit circle puts us here and here. My lines are pretty straight too, huh? So we got pi over 4 and 3 pi over 4. We could write the coordinates in for this too. That will help. Rad 2 over 2, rad 2 over 2. And rad 2 over 2, rad 2 over 2. And if we were to even like try to make another connection here with the graph, you'd have a horizontal line at, and I'm kind of putting a lot in here, 0.7 something. This looks about 0.7. So here's your horizontal line 0.7, rad 2 over 2. Good, we know my two solutions. Now if we go back to the graph, doesn't this look like it should be pi over 4 and 3 pi over 4? Based on where these points are, more or less? Yeah. Uh-huh.
What if it's like two graphs and like one of them is a slope and then this one's a periodic? How would you find it then?
Oh, it wouldn't apply in that case because it's not linear. Like, we're not looking for, you're looking for a specific height that's constant, right?
Yeah.
So if it was something that was like curved, it would be equal to an actual equation. So it would be different. I mean, we could work with it, it'd just be more complex. We'd have to use substitution or elimination on it. All right, what do we add to each of these? 2 pi in and 2 pi in. And to point this out, I know I talked about this. What's the criteria for n? It has to be a positive, and that might be the definition of an integer. Can't remember. I haven't taught algebra 1 in a while.
What is the definition?
So we can just write integers, but positive or negative. And that will get us at all of our solutions. There's your answer. Pi over 4 plus 2 pi n and 3 pi over 4 plus 2 pi n.